Hey guys, so I came across this video on LinkedIn and this question popped into my head. Which of the technologies are better for self-driving cars? LiDAR remote sensing or cameras? Let's see what Elon Musk has to say about it.
LiDAR is a fool's errand, and anyone relying on LiDAR is doomed.
What Elon is mentioning makes absolute sense. So in today's video, we are going to take a look at each of these technologies and evaluate their pros and cons. I personally use LiDAR remote sensing for my projects and I believe it's one of the greatest technologies out there. In fact, I used it for land use and area detection with machine learning. But let's take a step back. What is LiDAR? Nowadays, almost all of us use location-based applications such as Google Maps or Uber. These applications use satellite remote sensing to capture the location of roads, buildings, or almost every other thing on the Earth's surface. These days that we encounter so many issues related to climate change, satellite remote sensing is a wonderful tool that is used to evaluate the environmental changes that happen every day. LiDAR, which stands for Light Detection and Ranging, is a remote sensing method that uses light in the form of a pulsed laser to measure ranges to the Earth. It measures the distance to a target by illuminating that target with laser light and measuring the reflected light with a sensor. Differences in laser return times and wavelengths can then be used to make a digital 3D representation of the target in the surrounding area. This is accomplished by a sensor being placed on the vehicle. At first, it may sound like a great idea, but it's so much challenging to do it. One of the challenges is its price, which is very high, and the end customer won't be happy about it. So it's inconvenient to use it on cars. Besides, LiDAR can detect there is an object nearby, but it can't say what it is. Therefore, Tesla uses a radar system that works similarly but uses radio waves instead of lasers. It is heavily focused on pairing data gathered from radio waves with computer vision and a neural network. This is better because it can help the computer to act like the human brain when it sees something. In fact, it has more info, so it performs even better than our minds. This is also why LiDAR is not a good option, because it can't tell the difference between another car or a living thing or even a plastic bag. Let's look at our alternatives. The other technology is AI-based image processing, which uses artificial intelligence to detect objects in an image. This idea can be practical when you have tons of data or images to train a model to detect various types of objects in a photograph. Besides, cameras have a fraction of the cost of the LiDAR technology. By now, Tesla has an enormous database of images that their cars have gathered. Therefore, they are doing the right thing. So I covered some of the pros and cons of each of these technologies and established that this is the matter of different applications of the technology that we are choosing. LiDAR is good, but not for autonomous vehicles. And until we have some more advanced version of it that can surpass cameras in terms of affordability and usage, it's better to stick to cameras. Therefore, Elon is right about this.
I should point out that I don't actually super hate LiDAR as much as it may sound, but at SpaceX, SpaceX Dragon uses LiDAR to navigate to the space station and dock. Not only that, SpaceX developed its own LiDAR from scratch to do that, and I spearheaded that effort personally. Because in that scenario, LiDAR makes sense. And in cars, it's friggin' stupid. It's expensive and unnecessary, and as Andre was saying, once you solve vision, it's worthless. So you have expensive hardware that's worthless on the car. We do have a forward radar, which is low cost and is helpful, especially for occlusion situations. So if there's like fog or dust or snow, the radar can see through that. If you're going to use active photon generation, don't use visible wavelength, because with passive optical, you've taken care of all visible wavelength stuff. You want to use a wavelength that is occlusion penetrating, like radar. So LiDAR is just active photon generation in the visual spectrum. If you're going to do active photon generation, do it outside the visual spectrum. in the radar spectrum. So like at 3.8 millimeters versus 400 to 700 nanometers, you're going to have much better occlusion penetration, and that's why we have a forward radar. And then we also have 12 ultrasonics for near field information, in addition to the 8 cameras and the forward radar. You only need the radar in the forward direction because that's the only direction you're going real fast. So I mean, we've gone over this multiple times, like, are we sure we have the right sensor suite? Should we add anything more? No.
Well, that's it for this video. I hope you enjoyed and learned something new. Don't forget to like, subscribe and turn on the notification bell for more amazing videos. We'll see you soon.